We'll move to the next chapter of the module 4. Module 4 basically consists of chapter 3, chapter 4 and chapter 7. The entire chapter 3, 4 and just two sections of chapter 7. So we have completed chapter 3, which was nothing but from here till here. Now we have to talk about application and domain specific. If you have to see the syllabus, see we completed these two things. Now we have to move to these two things. And they also have the sub little parts. That's not a problem. So if you have to see in this, you have to talk about washing machine application specific embedded system. So wait, I just want to go down to see automotive. It is domain specific. So in the syllabus they have talked about washing machine, that is application specific, and automotive they have told about domain specific. So application specific you have to talk. If they ask like instead of washing machine, mentioning washing machine, they have asked you about application specific, you have to do washing machine. And instead of automotive, if they have asked domain specific, then you have to talk about automotive. There is also like comparatively differentiation in my the notes which I have prepared. So let's move on or jump into the action for this. So this is basically the functional diagram which you have to remember. Take a screenshot or whatever you want to do, or pause and draw it down. If they ask about the functional diagram, you have to like draw this. It's very simple, right? You just have to draw two cylinders, one rectangle or box cuboid. Simply fill it with the water and some motor shape of things, basic things. So see, if you have to see, there is one water inlet pipe. Basically sometimes inlet pipe also comes from this region, in some washing machines. This is the top load, basically in top load diagram. Don't go and draw for front load, simply unnecessary, too much of in a front load you cannot describe all the components properly, so that's why I'm taking top load. Water outlet where the body goes. Body is nothing but the body of the washing machine, the outer part you see. One is inner tub and one is outer tub. Inner tub is for washing purpose, okay. Where these holes are nothing but if you observe your washing machine tub, it will having steel surfaces with small holes. That holes, what they do, like the cloth is rubbed to the surface. So at that time, what happens? The dirt and everything is scratched along that pores, and it goes behind this. From inner tub, it goes to outer tub. From outer tub, the dust is all there is a part where that filter thing where it will be stuck over there, and it will clean and everything. Then you have a keypad which is basically somewhere over here. If you close it above, you can see that, you can see starting start mode. You have that water level, how many levels of water you have to choose, temperature of water, which mode, fuzzy mode, some different types of modes are there. You have all the starting button, pause button, everything. And LED display is nothing but shows the time duration. There's not just two, sometimes in latest there are like four of them, which displays hours also sometimes, because basically it, in fully automatic it shows even the hours and everything. This is was the structure diagram. You just have to like remember the definition part. See, L1 is nothing but illustrates the application specific aspects of embedded system with example. LO2 is nothing but understand domain specific aspects. Yeah, okay. Washing machine application specific embedded system. Or you see embedded, they have to talk about unlike general purpose system, embedded system are highly specialized and cannot be replaced by system like that. Specific, they are designed for specific purposes or process or something like that. Embedded systems are application and domain specific, built for specific functions in defined domains. Okay, let me highlight this as well. Components of washing machines. So there are sensors. What type of sensor? There are water temperature sensor and water level sensors. Sometimes there are also door sensor. Like if the door is open, it indicates with a voice or a beep sound saying and usually in my home the washing machine says dhakkan ko band kare, like that and all. Or in English it say please close the door or something, a beep sound and all will come. Actuators performs actions based on control signals. What are the control signals? It is taken from the sensors itself. Motorized agitator, uh, tumble tub motor. Tumble is like spinning, zing and all. Motorized agitator like agitator. Okay. Water drawing pump, inlet valve controlling water flow. These are the four actuators they have mentioned. Control unit. It's mostly like microprocessor or controller based, interfaces with sensors and actuators, runs control algorithms, receives sensors input, and commands actuators according. Sorry, so here I told actuators it takes information from sensor. That's wrong. Any human does mistakes. What is the user interface? You can talk about keypad, that buttons you have, and you have display LED displays. Now we'll see functional working. So we have washing phase, you have control panel controls. See, in washing phase you have wash phase and spin phase. Washing phase nothing. In wash phase you have like top load and front load. You have to talk about that. In top load, the motor will run like in clockwise and anti-clockwise direction. Okay, that's how the more clothes will go up and down. Excuse me. In this, and in front load models, there is no the anti-clockwise and clockwise rotation. It's just only one side of rotation, that is tumble and plunge type of repeatedly spinning in the water. Spins phase, you have water is pumped out of the tub, like all the water. First the water is all pumped, pumped out of the tub. So first you can see the water outside, all the water goes, everything. Once the complete water is gone, or like how much ever, if the sensor is like indicating or sensing the water level, it is gone out. Then what happens, the spinning starts, like the tub spins at very high RMP, like rotations per minute, and that force, by the centrifugal force, all the water is like gone out. In control panel controls, you have like wash mode, spin mode, rinse mode, and other four also, like fuzzy mode, like sometimes many different modes are there. For now you just three things are enough. Type of close selector, light, medium, heavy duty. Type of, you can say, water inlet also, high, water level 1 2 3 1 to 8 levels, like basically less water to like completely filling till the mouth, like that. And then you have temperature level also. Design variations. Washing machines differs by manufacturer and model, but share the same basic principle and control structure. Basic control includes timer, like how much time will it take to complete. Cycle selector, water temperature selector, load size selector, start button. So see, these few things from here are coming. See, this is a cycle selector. These things, water temperature selector, load size selector, like how much load you are putting in the washing machine. Even that is there sometimes. Everything is in latest washing machine. Everything is mechanical parts include motor, transmission, clutch, pump, agitator. Too many things. You don't have to explain too much or mention too much. Control system architecture, you have to draw about say diagram, and talk about microcontroller board interfaces with input devices, that are keyboard or keypad, sometimes sensors, water temperature and water level, or door also, actuators, motor control for agitator and tub, water inlet and valve control, water inlet valve controls, also sometimes outlet valve as well. Output devices nothing but LEDs or LCD displays. That is for understanding how much time is left. The control executes control algorithm that reads the sensor data, controls the actuator accordingly, and provides user feedback through display. Just talking about the summary, how they have, you can just read it once. If you want, I can read it for you. You can just skip if you don't want to listen. Embedded systems are designed specifically for particular applications. Washing machines exemplify this by integrating sensors, actuator, and control units. So you just have to always mention about sensors, actuators, and control specialized unit. For laundry, the embedded control system manages washing cycles, water flow, temperature, and mechanical operations via user input and sensor feedback. Despite variations in design across models, the functional embedded system architecture and working principle remain consistent. So here are some potential questions. We have quiz questions. I might say the answer immediately, so you just have to pause before I say the answer. Which of the following is not a sensor in washing machine embedded system? Water temperature sensor, water level sensor, agitator, motor, none of the. Come on, it's very simple. These both are sensor and this is not a sensor. I won't highlight it because you have most of the people, oh shit. Don't go for none of the above. Usually people go none of the above. What is the main function of actuator in the washing machine? To sense the water level, that is the sensors. To control the water flow and move clothes. To display washing status. To select washing modes. To control the water flow and moving clothes. It's mostly like water inlet thing, right? It's like B for that. In a front-loading washing machine, how are clothes washed? It's tumbled and plunged repeatedly in water. The same sentence is used in the definition. What does the control unit primarily do? Displays washing instructions. Control unit reads sensors and controls actuator. This is the perfect answer. Okay. Pumps water into the machine. Spins. Automotive and domain specific example of embedded system. This is the second part of the chapter 4. We'll see that in the next part. Okay. So for that we need this example. I mean diagram, car, so many things. So how many? 12, 14, 15. Okay, so if you go like this, it's like going like this. So you have 15 things in this, but you don't have to, basically remember all those things. We'll see in the next video. Bye bye.